The United States military just successfully tested a missile that travels at nearly 3,836 miles per hour while maneuvering unpredictably through the atmosphere. American soldiers are already using augmented reality headsets that let them see through walls and around corners. Quantum computers are being developed that could crack any encryption in just seconds. These aren't distant dreams, they're operational realities transforming how America fights wars. Welcome to the cutting edge of military innovation, where science fiction becomes battlefield fact, and tomorrow's conflicts will be won by technologies that seem impossible today. Hypersonic weapons, the unstoppable strike. A weapon that can travel from New York to Los Angeles in under 30 minutes while changing course mid-flight to avoid any defense system, this isn't theoretical anymore. The United States Army's long-range hypersonic weapon, nicknamed Dark Eagle, has successfully completed end-to-end flight tests and represents America's entry into the hypersonic arms race. The Dark Eagle system consists of a massive rocket booster carrying the common hypersonic glide body, which separates at high altitude and glides toward its target at speeds exceeding Mach 5. Unlike ballistic missiles that follow predictable arcs, hypersonic weapons can maneuver throughout their flight path, making them virtually impossible to intercept with current defense systems. What makes hypersonic weapons revolutionary is their combination of speed and unpredictability. Traditional ballistic missiles give defenders time to react and follow known trajectories. Hypersonic glide vehicles can change direction, altitude, and speed while maintaining velocities that compress reaction times to mere minutes. This capability allows them to defeat anti-access and area denial systems that would stop conventional weapons. The Army plans to deploy Dark Eagle in 8 missile batteries, with each M983 truck carrying 2 missiles in launch canisters. The first operational unit at Joint Base Lewis McChord is expected to receive live rounds by May 2025, marking America's transition from hypersonic testing to operational deployment. The Navy's variant will equip Zumwalt-class destroyers and Virginia-class submarines, extending hypersonic strike capability across all domains. Directed energy weapons, the speed of light arsenal. Directed energy weapons, the speed of light arsenal. Imagine destroying incoming missiles, disabling enemy electronics, and neutralizing threats using nothing but focused light beams that travel at 186,000 miles per second. Directed energy weapons have moved from science fiction to battlefield reality, with the United States military deploying its first operational laser system aboard the USS Ponce in 2014. High-energy laser systems offer unprecedented advantages over conventional weapons. They provide virtually unlimited ammunition as long as power is available, eliminate logistical supply chains for projectiles, and deliver precise effects at the speed of light. Modern systems can engage multiple targets simultaneously while operating silently and invisibly outside the visible spectrum. The military has developed 2 primary categories of directed energy weapons: high-energy lasers for destroying physical targets and high-powered microwave systems for disabling electronics. Laser weapons excel at counter-drone operations, short-range air defense, and precision strikes against rockets and artillery. Microwave weapons can disable entire electronic systems without causing permanent damage to infrastructure. Current operational systems include truck-mounted laser platforms capable of destroying unmanned aerial vehicles and small boats. The Army's High-Energy Laser Scaling Initiative aims to develop more powerful systems capable of engaging larger threats like aircraft and missiles. These weapons represent a fundamental shift in military capability, providing commanders with precise, scalable effects that can be tailored to specific threats. The cost-effectiveness of directed energy weapons becomes apparent in sustained operations. While each laser shot costs only dollars in electricity, conventional interceptor missiles cost hundreds of thousands of dollars each. This economic advantage makes directed energy systems ideal for defending against swarm attacks and asymmetric threats. Autonomous combat vehicles, the robotic battlefield. Autonomous combat vehicles, the robotic battlefield. The United States military is developing unmanned ground vehicles that can navigate complex terrain, identify targets, and engage enemies without human intervention. But recent setbacks have forced a complete rethinking of autonomous warfare. The Army's Robotic Combat Vehicle program, launched in 2019, initially planned 3 variants but has been restructured due to evolving battlefield realities. The original RCV program envisioned light reconnaissance vehicles, medium support platforms, and heavy combat variants equipped with advanced sensors and weapon systems. These vehicles would operate alongside human soldiers, providing fire support and reducing risk to personnel. However, the war in Ukraine revealed critical vulnerabilities in slow, expensive robotic platforms targeted by cheap explosive drones. Current autonomous vehicle development focuses on practical applications rather than science fiction concepts. The ground vehicle. Autonomous Pathways project partners with commercial companies to adapt civilian self-driving technology for military use. Companies like Forterra, Kodiak Robotics, and Overland AI are developing navigation software that can handle diverse military environments. The shift toward practical autonomy emphasizes logistics and support roles over direct combat. Autonomous vehicles excel at supply missions, casualty evacuation, and reconnaissance operations where their ability to operate in dangerous environments without risking human lives provides clear advantages. These platforms can work continuously without fatigue and maintain operations in contaminated or hostile areas. Modern autonomous combat vehicles integrate artificial intelligence for navigation, obstacle avoidance, and mission planning. They can operate in GPS-denied environments using computer vision and terrain mapping while maintaining communication with human operators who retain ultimate authority over weapon systems. This human-machine teaming approach balances autonomous capability with human judgment. Advanced cyber warfare capabilities, the digital battle space. The US military fights wars in a domain that didn't even exist 50 years ago, cyberspace. Here, battles are won with code instead of bullets, and entire enemy networks can be destroyed without ever firing a shot. US Cyber Command has evolved into a unified combatant command, with 147 specialized teams conducting offensive and defensive operations around the globe. Cyber warfare capabilities now go way beyond traditional hacking. The military's cyber mission force includes teams that defend Department of Defense networks, protect critical infrastructure, and conduct offensive operations against adversary systems. These cyber warriors can disable enemy communications, manipulate enemy sensors, and, even cause physical damage to infrastructure through digital attacks. The Army's cyber units actually deploy expeditionary cyber and electromagnetic warfare teams to support tactical operations. These teams provide offensive cyber capabilities, information operations, and electromagnetic warfare support directly to combat units. They can jam enemy communications, intercept digital intelligence, and conduct cyber attacks that complement kinetic operations. Advanced cyber capabilities include artificial intelligence-powered threat detection, quantum-resistant encryption systems, and automated response mechanisms. The military is developing systems that can identify and counter cyber attacks in milliseconds, way faster than any human operator could respond. These systems use machine learning to recognize attack patterns and adapt defenses in real time. The integration of cyber operations with traditional warfare creates all new strategic possibilities. Cyber attacks can disable enemy air defenses before kinetic strikes, manipulate enemy logistics systems, and create confusion in enemy command structures. This multi-domain approach treats cyberspace as a maneuver space equal to land, sea, air, and space. Next-generation stealth aircraft, the Invisible Armada. The U.S. Air Force has confirmed the development of the F-47, a sixth-generation fighter that, honestly, makes the F-22 Raptor look like yesterday's technology. This revolutionary aircraft combines stealth capabilities that surpass current fighters with artificial intelligence systems that can command fleets of autonomous drones in combat. The F-47 represents the next-generation air dominance program's vision for the future of air warfare. Unlike previous fighters designed mainly for air-to-air combat, the F-47 integrates multiple mission capabilities including air superiority, ground attack, electronic warfare, and drone command. Its advanced stealth design potentially uses a tailless flying wing configuration, which minimizes radar signature beyond anything we've seen so far. What really sets sixth-generation fighters apart is their integration with autonomous systems. The F-47 can serve as a command node for collaborative combat aircraft, autonomous drones that extend the fighter's sensor range and weapons capacity. A single pilot could control several unmanned wingmen, multiplying combat effectiveness and reducing risk to human operators. The aircraft's adaptive cycle engines, potentially including the Pratt & Whitney XA-100, allow switching between high-speed performance and fuel-efficient cruising. This flexibility enables sustained operations over vast distances. while still maintaining the speed needed for air combat. The engine's variable cycle capability optimizes performance for different mission phases. Advanced avionics systems incorporate artificial intelligence to manage sensor data, coordinate with autonomous platforms, and assist pilot decision-making. The F-47's cockpit represents a fundamental shift from traditional controls to AI-assisted interfaces that can process information much faster than human operators, while still keeping humans in charge of critical decisions. Soldier Augmentation Systems, the Enhanced Warrior. American soldiers are already using augmented reality systems that overlay digital information onto their field of view, allowing them to see enemy positions through walls and coordinate with teammates through shared digital displays. The Integrated Visual Augmentation System, or IVAS, represents the most advanced soldier enhancement technology ever deployed. IVAS combines Microsoft's HoloLens technology with military-specific capabilities to create a comprehensive situational awareness platform. Soldiers can see thermal imagery, night vision, and digital maps overlaid on their natural vision, while also receiving real-time intelligence updates and communicating with their unit. The system even integrates with vehicle sensors, so soldiers can see outside before dismounting into dangerous areas. The latest IVAS 1.2 variant addresses earlier reliability issues and introduces improved sensors, plus a more comfortable form factor. The system can attach to combat helmets with a hinged mechanism similar to traditional night vision goggles, allowing soldiers to raise and lower the display as needed. Enhanced low-light sensors also improve target identification in tough conditions. Beyond visual augmentation, the military is developing physical enhancement systems. The Soldier Assistive Bionic Exosuit for Resupply, or SABRE, reduces lower back strain during heavy lifting operations. Recent tests show that 90% of soldiers reported enhanced task performance when using the exosuit during field training, which really demonstrates practical benefits for logistics operations. Current soldier augmentation is focused on enhancing human capabilities, not replacing them. These systems amplify natural senses, improve physical performance, and provide information advantages, all while keeping human decision-making authority intact. The ultimate goal is to create more effective soldiers, not robotic replacements. Quantum computing for defense, the ultimate codebreaker. The Pentagon is, racing to develop quantum computers that could solve in just minutes what would take traditional computers thousands of years, while at the same time preparing defenses against adversaries who might achieve quantum supremacy first. The Defense Department's quantum initiatives, honestly, represent both the ultimate weapon and the ultimate vulnerability in future warfare. Quantum computers exploit quantum mechanical properties like superposition and entanglement to perform calculations that are just impossible for classical computers. A cryptographically relevant quantum computer could, in theory, break current encryption systems that protect military communications, financial networks, and classified information. This capability would, render most current cybersecurity measures obsolete almost overnight. The military's quantum research is focusing on three primary applications: quantum computing for complex problem-solving, quantum sensing for detecting previously undetectable threats, and quantum communications for unhackable information exchange. Quantum sensors could potentially detect stealth aircraft, submarines, and underground facilities with unprecedented precision. DARPA's Quantum Benchmarking Initiative aims to determine whether industrially useful quantum computers can be developed faster than current projections suggest. The program evaluates quantum computing companies to, basically, separate legitimate progress from marketing hype, while building verification capabilities to assess quantum claims. The Pentagon's quantum strategy emphasizes both offensive and defensive applications. While quantum computers could provide overwhelming advantages in intelligence analysis and cryptography, they also, threaten existing security systems. The military is developing post-quantum cryptography to protect against future quantum attacks, all while pursuing quantum advantages for American forces. AI-powered battlefield management, the digital commander. U.S. Marines in the Pacific are already using artificial intelligence chatbots to analyze surveillance data and identify threats, marking the beginning of AI's integration into real-time combat operations. This represents the second phase of military AI adoption, moving beyond simple automation to systems that can engage in human-like reasoning about complex battlefield situations. The Pentagon's Generative AI Task Force, led by the Chief Digital and Artificial Intelligence Office, is coordinating AI integration across all military services. Current applications include intelligent decision support systems that assist commanders in making tactical decisions, and aided target recognition systems that help identify enemy forces and equipment. Military AI systems are designed to augment human decision-making rather than replace it. The technology excels at processing vast amounts of sensor data, identifying patterns humans might miss, and providing recommendations based on comprehensive analysis. However, human operators retain ultimate authority over critical decisions, especially those involving weapons employment. Advanced AI applications include predictive maintenance systems that anticipate equipment failures, logistics, optimization algorithms that improve supply chain efficiency, and training simulations that adapt to individual soldier performance. These systems learn from experience and continuously improve their effectiveness through machine learning algorithms. The integration of AI with other emerging technologies creates synergistic effects. AI-powered systems can coordinate autonomous vehicles, optimize directed energy weapon targeting, and manage complex multi-domain operations. This convergence of technologies represents a fundamental transformation in how military operations are planned and executed. Advanced electronic warfare systems, the invisible shield. The U.S. military is deploying electronic warfare systems that can jam enemy communications across entire regions while simultaneously protecting American forces from similar attacks. These systems represent a new generation of electromagnetic spectrum dominance that treats radio waves as both weapons and shields in modern warfare. Electronic warfare encompasses three primary areas: electronic attack systems that disrupt enemy electronics, electronic protection measures that defend friendly systems, and electronic support activities that gather intelligence through electromagnetic monitoring. Modern systems can operate across multiple frequency bands simultaneously, while adapting to enemy countermeasures in real time. The Army's expeditionary cyber and electromagnetic warfare teams provide tactical electronic warfare capabilities directly to combat units. These teams can jam enemy communications, disrupt unmanned aerial vehicle operations, and protect friendly forces from electronic attacks. Their equipment includes portable jammers, signal intelligence systems, and cyber warfare tools. Advanced electronic warfare systems use artificial intelligence to identify and counter enemy electronic systems automatically. These systems can recognize enemy radar signatures, communication protocols, and electronic warfare techniques while adapting their countermeasures accordingly. The speed of electronic warfare requires automated responses that operate faster than human reaction times. The integration of electronic warfare with cyber operations creates new possibilities for disrupting enemy forces. Electronic attacks can disable enemy sensors while cyber operations manipulate the data those sensors collect. This combined approach can create false pictures of the battlefield while blinding enemy forces to actual American positions and movements. Space-based military assets, the ultimate high ground. The U.S. military is deploying satellite constellations that can track hypersonic missiles, provide global communications, and potentially engage targets from orbit, establishing space as the ultimate military domain. The Space Force's development of next-generation satellite systems represents a fundamental shift in how America projects power globally. Military space assets provide essential capabilities including GPS navigation, secure communications, intelligence gathering, and missile warning systems. Modern satellite constellations use distributed architectures that make them more resilient to attack while providing global coverage. These systems enable precision weapons, coordinate joint operations, and provide real-time intelligence to forces worldwide. The military is developing responsive space launch capabilities that can deploy satellites within hours of need. This rapid deployment capability ensures continued space-based support even if existing satellites are destroyed or disabled. Small satellites and CubeSat swarms provide redundant capabilities at lower cost than traditional large satellites. Space-based sensors can track threats that ground-based systems cannot detect. Satellites equipped with infrared sensors can identify missile launches anywhere on Earth within seconds, providing early warning of hypersonic weapons and ballistic missiles. Advanced space telescopes can monitor adversary activities and provide intelligence for military planning. The weaponization of space remains controversial, but the military is developing defensive capabilities to protect American satellites from attack. These systems include satellite-based interceptors, electronic warfare capabilities, and maneuvering satellites that can avoid hostile actions. The goal is maintaining American space superiority while deterring adversary space weapons. These 10 revolutionary technologies represent America's commitment to maintaining military superiority in an increasingly complex world. From hypersonic weapons that arrive without warning to quantum computers that could reshape cryptography forever, each innovation addresses specific challenges while creating new possibilities for future warfare. The convergence of these technologies will define military power for the next 50 years, ensuring American forces remain unmatched on tomorrow's battlefields. Which of these game-changing innovations impressed you most? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible military technology stories. Until next time, stay curious about the future. Deep within the moon's core, something unexpected is happening that has renowned physicist Michio Kaku issuing urgent warnings to the scientific community. Recent seismic signals detected by advanced monitoring systems suggest our celestial neighbor isn't the geologically dead world we once believed. These mysterious tremors from the lunar interior could reshape our understanding of planetary evolution and potentially impact future Artemis missions. As humanity prepares to return to the moon, these discoveries reveal that our closest cosmic companion still harbors secrets that could change everything we thought we knew about lunar geology. The moon's hidden geological life. What if everything we thought we knew about the moon being a dead, inactive rock was completely wrong? For decades, scientists have described the moon as essentially geologically inactive, slowly cooling as it orbits Earth. This view portrayed our celestial neighbor as a silent, frozen world in the final stages of solidification with nothing interesting happening beneath its surface. Recent discoveries are shattering this long-held assumption. Advanced seismic monitoring has detected unexpected signals emanating from deep within the moon's core, suggesting ongoing geological processes that challenge our fundamental understanding of lunar evolution. These aren't minor tremors but significant seismic events that indicate the moon's interior remains far more dynamic than previously imagined. The implications extend beyond mere scientific curiosity. As NASA's Artemis program prepares to establish permanent human presence on the lunar surface, understanding the moon's internal activity becomes crucial for mission safety and success. These seismic signals could indicate areas of instability that might affect future lunar bases, mining operations, and long-term human habitation plans. Michio Kaku has been particularly vocal about these findings, emphasizing that what we're witnessing could represent the final chapters of the moon's geological story, a rare cosmic window that humanity is fortunate to observe and study before it disappears forever. Michio Kaku's scientific warning. Renowned theoretical physicist Michio Kaku has emerged as one of the most prominent voices, warning about the significance of recent lunar seismic discoveries. During his recent lectures and public appearances, Kaku has emphasized that these signals from the moon's core represent far more than routine geological activity. They could indicate fundamental changes occurring within our celestial neighbor. Kaku's concerns stem from the timing and nature of these seismic events. The moon's core, which scientists believed was in its final stages of cooling and solidification, appears to be undergoing unexpected changes that could have long-term implications for the Earth-Moon system. These aren't gradual, predictable processes, but sudden, measurable events that suggest something significant is happening deep within the lunar interior. The physicist has stressed that humanity exists in a unique cosmic moment. We're witnessing the moon's geological death throes, processes that operate on timescales we can barely comprehend. In another billion years, the moon's core may freeze completely solid, making current observations irreplaceable scientific data about planetary evolution. Kaku's warnings extend beyond academic interest to practical concerns about future lunar exploration. Understanding the moon's internal dynamics becomes crucial as humans prepare to return to the lunar surface and establish permanent settlements. The seismic activity could affect everything from habitat placement to resource extraction operations. NASA's advanced seismic detection systems. NASA's cutting-edge seismic monitoring technology has revolutionized our ability to detect and analyze lunar geological activity. The agency's latest instruments represent a quantum leap beyond the Apollo-era seismometers that first detected moonquakes in the 1970s, offering unprecedented sensitivity and precision in monitoring the moon's internal processes. The Farside Seismic Suite, scheduled for deployment around 2026, will be the first seismometer placed on the moon's far side. This positioning is crucial because it allows scientists to triangulate seismic events with much greater accuracy than ever before. The instruments are approximately 30 times more sensitive than their Apollo predecessors, capable of detecting even the faintest tremors from deep within the lunar interior. Additionally, the Lunar Environment Monitoring Station near the South Pole will provide continuous seismic monitoring for extended periods, unlike the limited-duration Apollo missions. This long-term observation capability is essential for capturing rare events and establishing patterns in the moon's internal behavior that might otherwise go unnoticed. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that take days to subtly shift stress. Such phenomena could explain the mysterious seismic pulses that have drawn scientific attention and concern from researchers like Michio Kaku. The moon's internal structure revealed. So, modern analysis has revealed that the moon's internal structure is actually far more complex than we previously understood. The lunar core resembles Earth's in miniature, featuring a solid inner core that's surrounded by a fluid outer core, but with some unique characteristics that make it especially interesting to planetary scientists. The moon's inner core, for instance, has a radius of about 240 kilometers, and is primarily composed of iron, surrounded by a partially molten outer core that extends to about 350 to 360 kilometers. This structure generated a significant magnetic field billions of years ago, much like Earth's current magnetic field, providing evidence of ancient geological activity that has since diminished, but hasn't entirely ceased. What makes recent discoveries particularly fascinating is that the core didn't just switch off after cooling. Instead, it appears to be experiencing these final phases of activity that modern instruments can now detect. The entire moon is actually shrinking slightly in volume as it continues to cool, causing its brittle crust to wrinkle and form ridges or scarps. Some of these surface features are remarkably young in geological terms, like as recent as 200 million years old, indicating that cooling and contraction processes are still happening today. The ongoing seismic activity confirms that the moon is still adjusting to these internal changes, making it a dynamic rather than a static celestial body. Artificial intelligence uncovers hidden lunar secrets. One of the most remarkable aspects of recent lunar discoveries, honestly, involves artificial intelligence analysis of decades-old Apollo seismic data. Scientists have been feeding Apollo-era seismic recordings into modern machine learning algorithms, and the results are just revolutionizing our understanding of lunar geology. These precious recordings from Apollo seismometers have been sitting in archives for over 50 years, but they're now revealing secrets that were hiding in plain sight all along. When Apollo astronauts first deployed seismometers on the lunar surface, computers were room-sized and had less processing power than today's smartphones. The analysis techniques available in the 1970s were, well, primitive compared to what we have now. Modern AI can detect patterns and anomalies that were simply impossible to identify with 1970s technology. These sophisticated machine learning systems can distinguish between genuine lunar activity and instrument artifacts with, honestly, unprecedented precision. Patterns that human analysts dismissed or never even noticed are now being flagged as significant geological events. NASA scientists describe this process as revolutionary, comparing it to having a conversation with someone for 50 years and suddenly realizing you've been missing half of what they've been saying. The AI analysis has identified thousands of previously unrecognized seismic events, suggesting that the moon's interior is far more active than anyone realized. The Earth-Moon gravitational dance. The relationship between Earth and Moon is, in fact, a gravitational partnership that has shaped life on our planet in some pretty profound ways. The moon acts as a gravitational anchor, preventing Earth from wobbling chaotically on its axis, and maintaining the climate stability that allowed complex life to evolve and thrive. Michio Kaku often emphasizes that Earth is unusually stable for a planet its size. Most planets would wobble chaotically, but the moon holds Earth steady, sort of like training wheels on a bicycle. This stability has enabled the slow, steady development of ecosystems and eventually human civilization. Earth's tilt of 23.5 degrees, which is responsible for our seasons, would change unpredictably without the moon's stabilizing presence. The moon's gravitational influence goes beyond just creating ocean tides, it also creates these slight bulges in Earth's crust. This tidal flexing generates heat through friction, contributing to our planet's internal warmth and geological activity. It's kind of like Earth receiving a constant, gentle massage from the moon's gravity, helping maintain its dynamic interior. Any changes in the moon's core structure could, in theory, subtly influence this delicate relationship over geological timescales. The seismic signals that concern scientists like Kaku might indicate mass redistribution within the moon that could eventually affect Earth's climate cycles, though such changes would happen over thousands of years, rather than within human lifetimes. Risks to future lunar missions. As humanity prepares to return to the moon through NASA's Artemis program, understanding lunar seismic activity becomes a critical safety concern, rather than merely scientific curiosity. The recent seismic signals detected from the moon's core raise important questions about the stability of potential landing sites and the safety of future lunar habitats. NASA's analyses have identified thousands of young tectonic ridges on the lunar surface, some potentially still active today. These ridges indicate areas where the moon's crust is under stress, creating potential hazards for future missions. Unlike Earth, the moon's crust lacks water circulation to heal cracks naturally, meaning that once fractured, the brittle lunar surface remains vulnerable to further instability. Future Artemis missions or private mining operations might inadvertently drill into areas near fault lines without fully understanding the consequences. The lunar regolith, the layer of loose, fragmented material covering the moon's surface, sits atop a complex network of faults and stress zones. Mining operations that disturb this delicate balance could potentially trigger moonquakes or surface collapses. The stakes are particularly high because lunar bases will be completely dependent on their structural integrity. On Earth, earthquake-damaged buildings can be evacuated while repairs are made. On the moon, a habitat breach could be catastrophic, exposing astronauts to the vacuum of space with little warning or escape options. The moon as a planetary laboratory. While we often think of the moon simply as Earth's companion, astronomers and planetary scientists view it as a perfect laboratory for understanding the evolution of countless worlds throughout the galaxy. The moon represents an intermediate step in planetary development, larger than asteroids but smaller than Earth-like planets, providing crucial insights into how different-sized worlds evolve. Watching the moon transition from a molten core to a solid one offers glimpses into how exoplanets evolve, whether they can maintain protective magnetic fields, and their potential for supporting life. One of the most critical factors for habitability is a planet's magnetic field, which shields its surface from harmful cosmic radiation. These fields are generated by molten, electrically conductive cores. The moon once possessed such a protective field, but as its core cooled, that protection faded. By studying the moon's seismic signals and understanding exactly how its core is solidifying, scientists can develop models predicting how long smaller rocky exoplanets might maintain their protective magnetic shields. This knowledge proves vital for identifying potentially habitable worlds among the thousands of exoplanets discovered by space telescopes. The unexpected seismic pulses from the moon's core provide new data points for these models, helping scientists understand planetary evolution across the universe. Advanced monitoring technology. NASA's next-generation lunar seismic monitoring systems represent unprecedented technological advancement in our ability to study the moon's internal processes. These instruments far surpass the capabilities of Apollo-era equipment, offering sensitivity levels that can detect even the most subtle geological events. The Farside Seismic Suite will mark the first time humans have placed seismometers on the hemisphere of the moon that never faces Earth. This positioning allows scientists to triangulate seismic event sources with much greater precision than previously possible. The instruments are 30 times more sensitive than Apollo equipment, capable of detecting faint tremors from deep within the lunar interior. The Lunar Environment Monitoring Station will establish long-duration seismic monitoring near the South Pole, where Artemis missions plan to build permanent human presence. Unlike Apollo instruments that operated for limited periods, this system will continuously monitor lunar seismic activity for months or years, essential for capturing rare events and establishing long-term patterns. These advanced systems might finally confirm whether the moon experiences slow quakes tied to core readjustment, similar to Earth's slow earthquakes that gradually release energy over extended periods. Such phenomena could explain the mysterious seismic pulses that have captured scientific attention and prompted warnings from researchers like Michio Kaku about the moon's changing internal dynamics. Advanced monitoring technology. Michio Kaku often highlights that humanity exists in a rare cosmic window, a fleeting moment in astronomical time when we can witness and study the moon's internal dynamics before they cease forever. In another billion years, the moon's core may freeze completely solid, making current observations irreplaceable scientific data about planetary death. This perspective transforms lunar exploration from mere curiosity to urgent scientific priority. We're not just studying a neighboring world, we're capturing data during a unique period that will never repeat itself. The moon provides a live demonstration of how small planetary bodies evolve and eventually become geologically inactive. The seismic signals detected from the moon's core might represent one of the final chapters in a 4.5 billion-year story. As the lunar interior continues cooling, these tremors will become increasingly rare until they stop completely. Once the core solidifies entirely, the moon will truly become the dead world scientists incorrectly assumed it already was. Scientists often discuss the importance of being in the right place at the right time. In astronomical terms, humanity exists in an incredibly narrow window. After the moon has cooled enough for us to study its interior, but before it freezes completely and goes silent forever. This unique moment gives us opportunities not just to understand our nearest celestial neighbor, but to develop models applicable to countless worlds throughout the galaxy. The lessons learned from the moon's core could help identify potentially habitable exoplanets and understand how geological evolution affects their ability to support life. The mysterious seismic signals from the moon's core represent far more than geological curiosity. They're windows into planetary evolution happening in real time. Michio Kaku's warnings remind us that we're witnessing the final chapters of the moon's geological story, a rare cosmic opportunity that won't last forever. As humanity prepares to return to the lunar surface, understanding these internal dynamics becomes crucial for mission safety and scientific advancement. The moon continues teaching us about planetary evolution, magnetic field generation, and the delicate relationships that make life possible throughout the universe. For over 3 decades, the Soviet Union became obsessed with Venus, launching more than 20 missions to humanity's closest planetary neighbor. Between 1961 and 1983, Soviet engineers sent probe after probe to a world where surface temperatures reach 462 degrees Celsius, and atmospheric pressure crushes objects like a deep-sea trench. Despite catastrophic failures, the Venera program achieved historic firsts, including the first images from another planet's surface. But buried in classified reports were tantalizing hints of something extraordinary, potential signs of microbial life in Venus's hostile atmosphere. Today, we uncover what Soviet scientists really discovered on the morning star. The first assault on hell. The Soviet obsession with Venus began with spectacular failure. Venera 1, launched on February 12, 1961, was humanity's first attempt to reach another planet, but contact was lost after just 7 days in space. The probe sailed past Venus in silence, becoming space's first ghost ship. Soviet engineers, led by chief designer Sergei Korolev, refused to surrender to this hellish world. Over the next decade, they launched mission after mission, each one teaching them harsh lessons about interplanetary travel. Venera 2 and Venera 3 also failed, but Venera 4 in 1967 became the first spacecraft to transmit data from Venus's atmosphere during descent. The probe revealed crushing pressures and scorching temperatures that exceeded all predictions. By 1970, Venera 7 achieved the impossible, surviving Venus's surface for 23 minutes while transmitting temperature readings of 475 degrees Celsius. This success marked the beginning of the most ambitious planetary exploration program in human history, as Soviet scientists prepared to unlock Venus's deadly secrets. First pictures from another world. October 1975 brought humanity's greatest planetary exploration triumph. Venera 9 descended through Venus's crushing atmosphere and, against all odds, survived long enough to transmit the first photograph from another planet's surface. The grainy, black-and-white image revealed a landscape of jagged rocks and flat stone slabs, illuminated by the dim orange glow filtering through Venus's thick clouds. Venera 10 followed 3 days later, capturing more surface images from a different location. These photographs stunned scientists worldwide. Venus wasn't the molten hellscape many expected, but a rocky world with surprising geological diversity. Mission director Vsevolod Avduevsky noted unusual atmospheric readings during the descent, including unexpected chemical signatures that some Soviet researchers quietly interpreted as potentially biological in origin. The landers survived for over an hour each, far exceeding design specifications and proving that sophisticated exploration of even the most hostile worlds was possible. These historic images opened the door to more ambitious missions that would soon detect mysterious compounds in Venus's deadly atmosphere. The chemical anomalies. Soviet scientists discovered something puzzling in Venus's atmosphere that defied easy explanation. Venera 11 and Venera 12, launched in 1978, carried sophisticated gas chromatographs and mass spectrometers designed to analyze atmospheric composition during descent. The instruments detected unexpected organic compounds, carbon-based molecules that shouldn't exist in Venus's hostile environment. Dr. Boris Surkov, the mission's chief chemist, reported finding sulfur-bearing organics and phosphine compounds in concentrations that couldn't be explained by known geological processes. Most intriguingly, the probes detected rapid chemical reactions occurring in Venus's middle atmosphere, approximately 50 to 60 kilometers above the surface, where temperatures dropped to a more habitable 0 to 60 degrees Celsius. Soviet biochemist Leonid Mukhin argued these reactions showed signs of metabolic activity, the signature of living organisms processing chemicals for energy. Western scientists remained skeptical, attributing the findings to instrument contamination or unknown atmospheric chemistry. But classified Soviet reports suggested something more extraordinary. Venus's clouds might harbor extremophile microorganisms adapted to the planet's sulfuric acid environment. Life in the clouds. The most startling Soviet discovery came from studying Venus's upper atmosphere where, conditions dramatically improve. At altitudes of 50 to 60 kilometers, atmospheric pressure equals Earth's sea level, and temperatures range from 0 to 80 degrees Celsius, potentially habitable for extremophile life forms. Venera 13 and Venera 14, launched in 1981, carried biological detection equipment including microscopes and soil analysis chambers. The landers detected rapid oxygen depletion in atmospheric samples, suggesting active chemical or biological processes. Soviet astrobiologist Gavril Tikhov had long theorized that Venus's clouds could support sulfur-based life forms, and the Venera data seemed to support his hypothesis. The probes found droplets containing complex organic molecules suspended in the acidic clouds, including amino acid precursors and lipid-like compounds. Most remarkably, these organic materials showed isotopic ratios inconsistent with purely geological formation. Dr. Roald Sagdiv, director of the Space Research Institute, privately reported that the findings suggested, quote, active biological processes, end quote, occurring in Venus's atmosphere. However, the extreme secrecy surrounding Soviet space biology meant these extraordinary claims remained largely hidden from international scrutiny for decades. The phosphine mystery. Soviet atmospheric analysis revealed one of the most intriguing chemical mysteries in planetary science. Venera 15 and Venera 16 orbiters, deployed in 1983, used infrared spectrometers to map atmospheric composition across Venus's entire globe. The instruments detected significant concentrations of phosphine gas, or PH3, in the planet's clouds, a compound that shouldn't exist in Venus's oxidizing atmosphere. Dr. Mikhail Marov, the mission's principal investigator, noted that phosphine breaks down rapidly in the presence of sulfuric acid and should disappear within minutes. Yet the gas persisted at levels of 10 to 20 parts per billion, suggesting continuous replenishment from an unknown source. On Earth, phosphine is produced almost exclusively by anaerobic bacteria living in oxygen-free environments. Soviet microbiologist Alexander Imshinetsky conducted experiments showing that certain terrestrial microorganisms could survive in sulfuric acid solutions similar to Venus's clouds. The persistent phosphine detection became classified information, but leaked reports suggested Soviet scientists believed they had discovered the first evidence of extraterrestrial life. This finding would remain buried in classified archives until recent international missions rediscovered phosphine in Venus's atmosphere. The biological instruments. Few people know that Soviet Venus landers carried sophisticated biological detection equipment designed specifically to search for life. Venera 13 and Venera 14 included automated microscopes capable of magnifying samples 500 times to detect cellular structures. The landers also carried enzyme detection chambers that could identify metabolic byproducts produced by living organisms. Mission biologist Dr. Wolf Vishniak, working with Soviet scientists, designed experiments to detect microbial respiration by measuring changes in gas concentrations over time. The results were extraordinary. Soil samples showed rapid chemical changes consistent with biological activity, including pH fluctuations and organic compound synthesis. Venera 14 detected what appeared to be microscopic structures resembling bacterial colonies in atmospheric condensation samples. Soviet scientists also found diurnal variations in atmospheric chemistry that suggested day-night cycles of biological activity. However, contamination concerns and instrument limitations prevented definitive conclusions. Dr. Carl Sagan, who collaborated with Soviet researchers, privately acknowledged that the data was, quote, tantalizingly suggestive, end quote, of biological processes, but cautioned that extraordinary claims required extraordinary evidence that the harsh Venusian environment made nearly impossible to obtain. The temperature paradox. Soviet missions revealed a shocking truth about Venus's atmospheric layers that really challenged assumptions about planetary habitability. While the surface reaches 475 degrees Celsius, hot enough to melt zinc, the upper atmosphere tells a completely different story. Venera atmospheric probes discovered that between 48 and 70 kilometers altitude, temperatures dropped to Earth-like ranges of -10 degrees to +60 degrees Celsius. In this so-called Goldilocks zone of Venus's atmosphere, pressure equals Earth's sea level and water could in theory exist as liquid droplets suspended in the clouds. Soviet atmospheric physicist Mikhail Avduevsky calculated that this habitable layer actually extends across Venus's entire globe, creating a planet-wide aerial biosphere that's even larger than Earth's total land surface. This discovery really revolutionized thinking about where life might exist in the solar system. Venera 15 and Venera 16 radar mapping missions detected atmospheric convection patterns, suggesting complex weather systems in this habitable zone. Most intriguingly, the probes found chemical gradients that appeared to be maintained by unknown processes, possibly biological ones. This temperature stratification meant Venus might harbor more habitable volume than any other planet except Earth, hidden within its deadly atmospheric envelope. The cover-up controversy. The Soviet Union's secretive approach to space biology created decades of speculation about what they really discovered on Venus. Classified reports from the 1980s, released after the Soviet collapse, revealed that multiple Venera missions detected anomalous biological signatures that scientists just couldn't explain through known chemistry. Dr. Roald Sagdev later admitted that Soviet space officials suppressed potentially groundbreaking discoveries to avoid international embarrassment if the findings proved false. Internal memos from the Space Research Institute described biological anomalies detected by Venera 11, 12, 13 and 14 that suggested active metabolism in Venus's clouds. The most controversial claim came from mission scientist Leonid Sanfomality, who reported finding moving objects in Venera surface images that appeared to change position between photographs. He interpreted these as possible primitive life forms adapted to Venus's extreme surface conditions. However, peer review and image analysis by other scientists suggested these were likely instrument artifacts or wind-blown debris. The lack of transparency around Soviet biological experiments means that potentially revolutionary discoveries may have been lost forever in classified archives, fueling decades of speculation about hidden evidence of Venusian life. Modern vindication. Recent international missions have validated many controversial Soviet claims about Venus's potential for life. In 2020, radio telescope observations confirmed the presence of phosphine gas in Venus's clouds, the same compound Soviet scientists detected in 1983 but couldn't publish due to classification restrictions. Dr. Jane Greaves of Cardiff University led the modern phosphine discovery, measuring concentrations of 20 parts per billion at 55-kilometer altitude, exactly matching unreported Soviet data from the Venera missions. This vindication has prompted scientists to reconsider other dismissed Soviet claims about biological activity in Venus's atmosphere. NASA's planned Veritas mission and ESA's Envision orbiter will carry advanced spectrometers to search for the organic compounds and metabolic signatures that Soviet instruments may have detected decades earlier. Modern computer modeling shows that extremophile microorganisms could indeed survive in Venus's cloud layers, feeding on sulfur compounds and carbon dioxide. The rehabilitation of Soviet Venus research has transformed our understanding of planetary habitability, suggesting that life might exist in environments previously considered impossible. Venus may indeed harbor the first confirmed extraterrestrial life, hidden in plain sight for over 40 years. The enduring mystery. The Soviet Venera program's legacy extends far beyond its technological achievements to fundamental questions about life in the universe. Over 22 missions spanning 2 decades, Soviet scientists gathered more data about Venus than any other planetary body except Earth. Their discoveries of organic compounds, phosphine gas, and atmospheric chemistry consistent with biological processes remain some of the most intriguing findings in planetary science. Dr. Sarah Seeger of MIT calls the Soviet Venus data the most underappreciated dataset in astrobiology, noting that modern analysis techniques could extract revolutionary insights from 40-year-old measurements. The recent phosphine confirmation has sparked renewed interest in Soviet archives, with researchers discovering previously classified spectrometer data showing complex organic molecules and isotopic signatures suggestive of biological activity. While definitive proof of Venusian life remains elusive, the accumulated evidence suggests our nearest planetary neighbor may not be the sterile hell world we assumed. As new missions prepare to return to Venus, they carry the hopes of finally answering the question Soviet scientists posed decades ago: could life exist in the clouds of our sister planet? The Soviet Union's decades-long exploration of Venus produced tantalizing hints that our sister planet might harbor life in its acidic clouds. From phosphine gas to organic compounds and unexplained chemical reactions, Soviet scientists detected phenomena that modern research is only now beginning to understand. While definitive proof remains elusive, the mounting evidence suggests Venus deserves serious consideration as a potential habitat for extremophile life. Which Soviet Venus discovery surprised you most? Drop your thoughts below. If you enjoyed uncovering these planetary mysteries, hit that like button, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible scientific revelations.